So, hello all. Today, in the second video of the NLP projects playlist, we are going to see how to build your own text classifier. This text classifier will be building in such a way that it will be adaptable for any text classification use cases which you will solve in your future. All right. So, let's jump right into the video now. So, here, if you see, we have a data set called stock tweets sentiment. So basically what we are going to do is analyze the tweets about any stock. Okay. So here is a tweet. Aaron highlights from EASA, European plan for aviation safety. And it is given as 0. So here if you see actually in this data set, there are three labels, which is -1, 0, and 1, where -1 is negative, 0 is neutral, and 1 is positive. I hope that makes sense. Okay, so this is just a short introduction of what we are going to do and what is the data set we are going to use. Okay, so we are going to use Colab as usual. Okay, so yeah, let's start with setting a runtime to GPUs. Okay, so I hope you all know. We'll set it as GPU. All right, save. Um, okay. I'm gonna stop these and all. These are also my old sessions. Okay. Yes, I think this should now reconnect. Yeah, I hope now it's working. Now let's start with the installation as usual. Okay, like in the last video we installed, we should install again. Pip install transformers, data sets, accelerate accelerate, and then maybe we'll need evaluate, just for the sake of calculating some things like accuracy or any other metric of our choice. Okay. Other than this, I don't think we'll be needing anything. Okay, so let's install this. All right. Okay, now it seems to be installing. So we'll make this in a modular way, all right? Though it is in a Jupyter notebook, we'll make it as a modular code so that if anyone has GPU in local also, you can just copy paste this code and then refactor your imports alone and then it will work, all right? So first we'll have a section for config, okay, which will contain all the config for your models. Okay, so let me have it as class config. All right. Um. Oh, sorry. Class config will be equal to. All right. So now it's fine, and then we'll define some others as well. Okay. So we need a class for processing and loading the data set, okay, which is making the data set ready for your model input. So we'll have a data set file, all right. We'll have the name as class text classification data set, okay. And again, I'll make pass here, okay. Fine. And then next we will need a model file, all right. So we are just creating kind of a boilerplate template. Okay, so we'll be filling all these classes now. We'll be having text classification model here. Let's paste it and edit it. All right. Oh, sorry. Pass. And finally, what we would be having is our main file, which is just to run the codes. Okay, again we'll have it as if underscore name underscore equal to equal to, sorry, under main, we'll have it as pass. All right, so first what we are going to do is we'll have this dataset id. Okay, and I hope you all know the convention. So whenever you are having some config, it is when you're having it as a separate constants, right, which is not going to change it a feature in the script. So have it as a capital variable. Okay, let us should be in capital, indicating that it is a constant which is used for configurations. Okay, other than this, I think we can also set it as maybe the models checkpoint. Okay, we'll use BERT, or even we can use DistilBERT because it will be faster. Okay, we'll use DistilBERT. For those guys who aren't just aware about DistilBERT, it is just a smaller version of BERT. Okay, which is uh, distillated. The knowledge is distillated. Okay, though the size is reduced, it achieves almost the same performance, near to the same performance of the BERT. So, and we are not solving any complex use cases, so this model should be suffice enough. All right, so let me have another variable called model ckpt, which is just model checkpoint, and we'll store it here. All right, and other than this, what we would need, um let's see. All right, so let's see if this is working. Okay, yeah, it is working. Okay, so now what we'll do is we'll do a dunder init function. All right, so self. Okay, we'll first call the data set id. All right, since we have everything in config, we'll just call it from here itself, config dot dataset id. Okay, self dot model underscore checkpoint is equal to config dot model checkpoint. All right, so other than this, we'll be having some imports. Now we'll do that. Okay, so we'll need tokenizer. We'll need a model. Sorry. Other than this, I think we'll need a trainer and then training arguments. Okay, similar to what we done before. And from data sets, we will need data set as well as load underscore data set. Okay, and then we'll need pandas. All right, that's PD. All right, then I guess, yeah. So for those guys who are gonna make it as script, right? Like if you have a file called config, so you can just have it as maybe instead of having this as a class, paste all these into a separate file called config itself, config.py, and then do import config. All right, so that should work for you all. If you're just going to be model, or like you don't like Jupyter notebooks, in that case you can do this. All right, so now what we'll do is we'll also have our train test split, because we do need train test split, right? Sequence classification, since we are doing a sequence classification task, we also need that. We'll also do this. Okay, sklearn dot model underscore selection import train underscore test underscore split. All right. So now what we'll do is we'll have our tokenizer self dot tokenizer equal to auto tokenizer dot from underscore pre-trained. We'll just call this model CKPT, which we have here, right? Self dot model underscore CKPT, right? And then we'll also load our device which we'll need. Okay, and there are some other steps as well. So these are all should be should in config. So first we'll do a create data, right? Create data function of self. Here what do we need? So first we'll have a variable called self dot data, which is equal to load under data set of self dot data set underscore id. So here you can see there are two splits, right? Like we have train as well as we have test. So what we'll do is we'll just call the train. Oh, yep. So this is just to call the train splitter. Okay. We'll do a train test split by ourselves. But if you want, you can just call it as well. Okay. Okay. So now we'll make it as pandas, all right? Like I said before, it is in previous videos, right? It is very easy to work with pandas data frame. So data frame will be equal to self dot data of train dot two underscore pandas. So if you had some test split as well, right? Like you can have it as self dot train df and self dot test df. You can have it as train here and then test separately. All right. So now what we'll do is, what do we need here? We need the tweet and sentiment alone, right? So we'll take that alone. And like I said, since we are going it as a template, we're going to make it as template, right? We'll have that here itself. SRC column. What is your source column? Which will be tweet here, right? Tweet. And sorry. And then the target column would be sentiment. We'll copy this and then we'll create another variable called tgt column, which will have this. Okay. So now that should be fine. So we'll also call that here self dot src underscore column will be equal to config dot src. Is it working? Yes. Self dot tgt underscore column equal to config dot tgt underscore column. Yes. Now, sorry. Um, I think this should work. Yes. So what we'll do is we'll filter these columns alone from the data frame. Self dot df is equal to self dot df of we have our columns here, right? So self dot src underscore column and comma self dot tgt underscore column. All right. So now that's fine. So we'll have our df with these two columns alone. And like I said previously, we have 0, -1, and 1, right? Usually we shouldn't have a minus value. So what we'll do is we'll give, instead of -1, we'll give another value called maybe 2. Okay. So self dot df of self dot tgt underscore column will be equal to self dot, I think we can copy this, tgt column dot apply lambda x is to 2 if x is equal to -1, else x. So what it will do is it will go through each of the rows in that target column and it will check if x value, which is the target value, is equal to -1. If it is -1, it will change it as 2. Otherwise, it will be the same. All right. So this should return the data set like we need that. Okay. So next what we can do is, so for now what I'm going to do is we'll sample the data set, but if you want some better performance, you don't need to sample. That's your wish. Okay. So for faster running, I'm just sampling it to maybe 20,000. All right. So now what we'll do is we'll make a train test split. So self dot train underscore df comma self dot test underscore df, which is equal to, I'll just make it as if needed here and all, because usually we don't have negative values or samplings needed. So these two you can do if it is needed for you. All right. Self dot test df, which will be equal to train underscore test underscore split of self dot df comma, I think it is test size. I'm just gonna have a variable here, self dot test underscore size. Though we didn't define, we'll define it. Okay. And you'll have shuffle equal to true because we always need shuffling. All right. And random state, I'll have it as self dot seed. And usually for classification, it is good to do stratify equal to true. No, not true. We should give the column based on which it should split. Okay. So that what will happen is the split will happen in the same ratio what is there in the data set. So let's say like if it is 20%, 30%, and 50% in the data set. So similarly, it will be for train and test. Okay, the composition won't change. Sorry. Self.df of self.tgt underscore column. All right. I guess this is working. Now what I'll do is we need to define two of the variable, right? So we'll do that here. Self.seed. Sorry, I think first test size. So test underscore size will be equal to config dot test underscore size as well as self dot seed will be equal to config dot c. All right. So now we'll define that here. It's test underscore size will be 20%, which is 0.2, as well as for seed value, I prefer 0, but there are people who prefer 42. And if you want any other value, that's your wish. You can also do that. All right. So now what we'll do is we'll make this as a data set. Okay, Hugging Face data set. We are having it as pandas data frame now, but now it's time to change it as Hugging Face data frame because we have almost completed the pre-processing which is needed for us. Um, but there is another one thing pending. Okay, so we'll do that here as well. So we are calling the model as uncased, right? Which is it will be always lower. Okay, so what we can do is self dot df of self dot src underscore column will be equal to self dot df of self dot src underscore column dot apply of lambda x is to x dot lower. Okay, so what we are just going to do is we are having it as string, right? We are just uh, sorry, we are just making the string to lower. Okay, so here he has already done that, but in most of the cases we won't have it as like that. So again, if you have it pre-processed in such a way, you can avoid these. All right. So now we'll convert it as data set. Self dot train underscore data will be equal to data set dot from underscore pandas self dot train underscore df. Right. So similarly, we'll have our SDF. So yep. Now we will return both of these. Okay. Okay. So now what we need to do is we need to create a tokenization function. All right. Because we need to make it ready for the model input from here itself, right? So next we'll have a tokenization function. So yeah, so now let's do that. Okay. So for this, we need to have torch. Okay. Mm, yeah. Now let's do the tokenization function. Def tokenize underscore function of self, comma example will be um, model underscore input will be equal to self dot tokenizer of example of self dot src column, because we need to tokenize our tweets. All right, so we'll have truncation equal to true. Okay, and then we'll also have our padding equal to true. I think we can also set a value for max length. All right. Okay. So we need a max length. All right. So what we'll do is again we'll have it as max length. Okay. So similarly we'll make it here as well. Max length will be equal to config dot max underscore length. So we'll go in here. We'll do max underscore length, which will be equal to um we'll have it as 32. All right, 32 tokens. So next what we would have is device, because it is very important to set our device for the model. Okay, so now let's also have it device, which will be equal to, will have an import here as well, because like I said, people might do it separately, so I'm having it as a separate torch import here as well. Torch dot, sorry, CUDA if torch dot CUDA dot is underscore available. Okay, else simple CP. Okay, so let's run this as well. Now, I guess we have our inputs, but we still don't have our labels, right? Because we need something to predict, right? So what we are going to do is we are going to make that labels column as a tensor. All right. So what we'll do is labels equal to torch dot tensor of example of dot sorry self dot tgt column, right? Because we need to do a target column only, right? So the data type will be torch dot int, right? I guess this is fine. So now what we'll do is model input of labels will be equal to labels, right? So let's return the model inputs. Now we are just creating the function. So now what we'll do is we'll create a function for to map this. All right. So let's call this pre-process underscore function. Okay. Let's have it as self. Okay. So here what we'll do is we'll have our data being called here. Okay. So I'll say why we are having it as a parameter, because we already have it as train and test here itself, right? So let me explain. Okay. So but still, yeah, it's not needed. You can do without that as well. Okay. So self um self would be needed because we are just going to return it, right? So model input again will be equal to data dot map of self dot tokenize underscore function. Okay, we'll have it as batch equal to true. Okay, and then we'll also, sorry, we'll also remove the columns which we won't need. Okay, so which is those columns, data dot column underscore names. Okay, we'll remove those and we'll return the data set. Now, to avoid successive function calls, we'll create another function here. Maybe we'll call it as gen classification data set. Okay, I'll have it as self here as well. So what we'll do is train underscore data comma test underscore data will be equal to um here it is, yeah, create data, my bad, self dot create underscore data of, sorry, function parameters doesn't have anything. Okay, so it is gonna return. So now what we'll do is we'll tokenize it. So train underscore tokenized underscore data will be equal to self dot pre-process underscore function of train underscore data. So similarly, we'll have for test, right? So test here. Okay. I hope this makes sense. Okay. So we'll return these two alone. Train underscore tokenized underscore data, comma, test underscore tokenized underscore data. Okay. Now we have our dataset class ready. Okay. So next what we have is to create our model. So again, let us do some inputs here. We'll have torch. Um, I think this should have been there. Okay. So here it wouldn't have been needed, but here it is needed. Okay. So after this, we'll need evaluate. Okay. Um, and along with these, I guess we'll need a, a data collator. Okay. So that should have been added here. So we'll add a data collator with padding. Okay. So let's see if it is working. Okay. We have our init function out here. Okay. Def init of self. First, what we would do is we'll call, sorry, sorry. Yep, spelling mistake. We'll have our train data and test data as parameters. Okay. So that we can send the data files from our main file. Okay. Test underscore data. Right. So self dot train underscore data will be train underscore data, and self dot test underscore data will be test underscore data. All right. So along with these, we'll need our model, right? So model underscore CKPT, which will be config dot model underscore CKPT. And now, when we are doing a text classification problem, it is very important to define two dictionaries. Okay. So you can also automate it if you want. Okay. Uh, but I'm just having it in our config file. Okay. So here we did have our labels mapped from some tokens, right? So ID to label will be as 0 is to positive, sorry, neutral. Okay. 0 as neutral, and then 1 as positive. And remember, right, we changed 2 as negative. Sorry, -1 to 2. So we'll have it as negative. All right. So we'll also have a label to ID function. It is just the opposite. Neutral, sorry, is to 0. Positive is to 1. Oh, sorry. And negative will be as 2. Um, did I miss any commas? I think this is fine. Okay. So we'll again run this and then we'll call it here self dot id to label will be equal to config dot id to label. Yes. So self dot label to id will be equal to config dot label to id. Okay. So I think it should be in capital. So to id. All right. So next what we will have is our device. Okay. We'll need that here. Device will be config dot device. Then we'll need our eval metric. Okay. We'll have it as config dot eval underscore metric. Okay, so we'll have it here. Eval underscore metric will be equal to accuracy. Okay, so yep, I guess that's fine. I hope we defined our data device. Yes, that is done. So now we'll create our model. Self dot model is equal to auto model for, yeah, sequence classification. Auto model for sequence classification dot from underscore retrained will have our model CKPT. Okay, we need those. So self, okay, and id to label function will be self dot id to label, and then label to id will be equal to self dot label to id, and then we'll have device equal to self dot device. All right, so yeah, I think that's good. So after this we'll need our tokenizer as well. Self dot tokenizer equal to auto tokenizer dot from underscore retrain self dot model underscore CKPT. All right. So next we'll have our eval underscore metric, which will be equal to, sorry, we'll have it as accuracy itself. It's not needed. We'll always have it as one. So it's computer. We'll have it as like this. So evaluate dot load of self dot eval underscore metric. All right. I hope this makes some sense. Okay. So after this, we'll need our data collator. We'll define that as well. Self dot data underscore collator, which will be equal to data collator with padding of self dot tokenizer. All right. So I think we are ready for preparing our model for training. Okay, still we need to define our training arguments. That we'll do now. Okay, later. So first we'll create a compute metric function. Okay, this will have it as eval underscore bread. Okay, and I'm just going to take it from somewhere. Okay, So what we are going to do is we'll have predictions and labels written together, and yeah, we need to import numpy as np. So here it will calculate the accuracy. All right. So yeah, now that should be fine. Now what we'll do is we'll define our training arguments. Set underscore training underscore args. All right. So self will have it as return training underscore arguments of of didn't it get imported? Oh, sorry, my bad. Yep, now we are having it. So we need model out directory, which will have it as self dot model out directory. Okay. So after that, we'll need maybe number of epochs, we'll need learning grade, we'll need batch size. Okay. So let's define all of those. Though we don't have the variable, we'll just define it. Okay. Self dot, I think it is not here. Learning underscore rate will be equal to self dot lr self, oh, sorry, uh, per device underscore train underscore batch underscore size. Let's have it as self dot batch underscore size. Right? So we'll have the same for eval as well. Per device eval batch size. Okay, so we'll have the same batch size for both. Next, we'll have a parameter called weight decay parameter. Okay. Um, weight underscore decay equal to self dot weight underscore decay. Um, Other than this, um, next what will happen is let's set our evaluation strategy when it should evaluate. That is what it specifies. Okay, evaluation strategy will be epoch. At the end of each epoch, I need to do an evaluation. So save strategy will be the same. Okay. I think we'll also set this from the config itself. So because you might feel like, man, I'll do for steps. So that is completely all right. Okay. So self dot eval underscore strategy. So just a hint, when you guys are doing for steps, right? There will be another parameter needed for logging steps and save steps. Okay. That also needs to be specified. Just give me a minute. So yeah, we have a save strategy, which will have it as self dot save underscore strategy, right? Then I guess we'll need logging strategy. Guess logging underscore strategy. Okay, and then after that, I guess we'll need push to hub. Yes, that is there, which is like, whether we need to push it or not. Obviously, we need to push it, right? So that will be enabled as true. Okay. So other than this, I don't think anything will be needed. Oh yeah, I made a silly mistake here. Okay, now we don't have any of these, right? So we'll have it here. So I'll put it here itself. Self dot model out directory will be equal to config dot model out directory. Okay, then for self dot lr will have config dot lr r. Then we'll have self dot batch size will be equal to config dot batch size. All right, then we'll need our weight dk, which will be equal to config dot weight underscore dk. um Spelling mistake here, I guess. How is that defined? Okay, here we have eval, save, and logging strategy. Self dot eval underscore strategy will be equal to config dot eval underscore strategy. All right, and then what? Self dot save underscore strategy will be equal to config dot save underscore strategy, and then for self dot logging underscore strategy will have config dot logging underscore strategy. And for those guys who are thinking, man, we didn't even set an optimizer. Actually, defaultly the optimizer has been set to Adam. That's how it happens in Hugging Face. But if you do want, you can just add your own optimizer. Okay, so that is also there. So now, yeah, we'll set our config file. Okay, what all do we need? Eval metric is done. So from here, model out directory. I guess we'll paste this there. Okay. Um. Yep. Oh, sorry. Let's remove this, and then strategies. Right. I guess even push to hub can be a metric because all might not like to push it to hub. Okay. I'm also having that as a configuration. All right. Now, yep. Now let's decide devise all of these. So now we'll have it as distill word. Sorry, it should be string. Distill word hyphen stock tweet sentiment analysis. Okay. So we'll have this as 2e minus 5. Okay. So which is 0.00002. Okay. So batch size will have it as 16 maybe. Okay. If it is not suffice enough, we'll increase. Okay. So weight dk, for weight dk will have some small value. Okay, but not as small as um learning rate. Guess I've missed something. Yes. Epoch. Num training box. Yes. Self dot num underscore epochs. Okay. So let me put this above. We didn't set that. Okay. Um, we'll also add that here. Num underscore epochs equal to config dot num underscore epochs. Okay. And then we need that here as well. Num underscore epochs. Here we'll have it as a standard tree. Okay, for this we'll give it as 0.01. We'll have it as epoch. I hope you guys remember, right? I told you. So if you do it as steps it is, then you need to give a value for those steps. Okay, epoch. And then this will be true, right? I guess this is looking good. Okay, we'll anyway run this. I guess we need to call that here. Push underscore to underscore hub equal to config dot push underscore to underscore hub, right? So yep, we'll save do that here as well. Self dot push underscore to underscore hub. Now what we'll do is we'll do a def train function, okay, which will make a trainer. Okay, trainer will be equal to, or else we can also call it as a separate function, maybe. Mm, okay, model trainer. Okay, so we'll return the trainer itself. Trainer with the following parameters. Okay, so let's see what and all we need. Model will be equal to self dot model, and then args will be equal to self dot set underscore training underscore args parent. Okay, and then we need a data collator, right? Yes, data collator will be equal to self dot data underscore collator, and then we need test train and eval dataset. Okay, train underscore dataset is equal to self dot, what are we having it as? Oh yeah, train data. Train underscore data, and then for eval underscore dataset equal to self dot test underscore data. Okay, so now we'll create another function called def train and save and push to hub. Okay, so self, what we can do is oh, we didn't add compute metrics. Yes, compute underscore metrics. Isn't that compute underscore metrics? I guess it is. Okay, see if it is working now. Yeah, So I think we'll also have an S here. Okay. So self dot compute underscore matrix. Okay, now it's fine. Um, Now what we'll do is we'll call the trainer here, which is train underscore and underscore save and push underscore to, oh, sorry, self, my bad, model trainer. Okay, now that looks good. Why is this still even popping up? Compute matrix. Yeah, now it should be fine. We'll call trainer dot train. Okay, and then trainer dot push to hub. Okay, so that it will push everything. But if you want to save the model, that also you can do. I don't have space in my disk. Okay, so but still you can do trainer dot save underscore model and trainer tokenizer dot save pre-train. Okay, these two functions can be used, and then you can provide your output directory here itself. Okay, in this trainer dot save underscore model. Um, yes, I guess this is enough. Okay, I think we are done with the code almost. Now there is an important part. Like in the previous chatbot session, we need to upload it in Hub. Okay, notebook login, notebook underscore login. So you can click it here. In my previous video, I've shown you, so I hope that is not needed. I'm just taking some random ones from my old tokens. Okay, but make sure, like I said, write token should be used, not read token. So if you still don't understand like how to create the token, please do watch the previous video, which is of creating a chatbot, which is around 100 lines. Okay, so I've covered it in a short way that you can just watch it and build your own chatbot. In that, I've shown how to create your own token, right? So yeah, now let's create a data set. Classification data set equal to text classification data set. I guess that is what is the name, right? Yeah, that's good. I guess that's not needed. Text. I'll call it as train data. Test data will be equal to text. It's not even popping up. Okay, let me type itself. Classification data set. Yes. Dot gen classification data set. Do we have any parameters? I hope so not. Yes, we don't have any parameters. Okay, so now I guess we need to create another instance for model. Have it as a trainer class. All right. I'll rename it trainer because we are not having any model here, right? I'll also change it as model trainer. Yep, that looks good. Text classification model in text classification inner doctrine and save and push underscore to underscore hub. Here we need to pass our train data as well as test data because we have set it as parameters here, right? Okay, so let's run this. I don't even know why it's coming this. Let's be control X and control V. Now it's looking good. Yes, so let's run it. So now the model is being downloaded, the data is getting downloaded. Okay, column is not in data set. Column train is not in data set. Okay, so let's see. Int data dot column underscore names. Okay, so let's debug it. Oh, it is not even printing it. Column train not in the data set. Okay, so usually it will have it as feature. So let's try like this maybe. Okay, let's see if it is working. What? Um, where is the error arising? Column train is not in the data set. Just give me a minute. Just give me a minute, guys. Okay, I'm just checking the error. Mm, is it even giving? Oh, yep, got it. So usually here we are giving a split, right? So that will be needed. Sorry, my bad. So let us run it again. Okay, it should be good. Now, yes. So here, if I have a train, I should remove that. Yeah, it's not right. Good. Yep. Let's see now. Okay, now is getting mapped. Let me sample the dataset. Oh, I guess we should stop this. Just go ahead. Model trainer is not defined. Okay. Text classification model trainer. Now, what we'll do is we'll restart the session. Okay. Also, here we didn't store it in a variable. Self.df. Yeah. Now we'll restart the session. Okay. I guess it is already around an hour of recording. Yep. So let's see. Let's run it from the first. Hope this would work. I'm just gonna copy and paste it here. And guys, again, don't say to anyone, don't show your token to anyone, okay? Because that might get misused. DistilBERT for text classification got an unexpected keyword argument called device. Okay, so doesn't it take device? Yeah. Then what we'll do is we'll remove this and make it as dot to self dot device. Now I think that should work. Okay, but the important thing is we didn't do another thing, okay, which is very important. Having the number of labels. Okay, so self dot num underscore labels is len of self dot id to label. If you want, you can also explicitly specify it in your config and then call it. But usually we're already having the mapping for each, right? So it wouldn't be needed. Okay. Num underscore labels equal to self dot num underscore labels. Okay. Now this should work. So let's see. Okay. Now it's getting tokenized. Let me see if the batch size is good or else even we can increase it. Okay, text classification trainer is not defined. What? It is here, right? Oh, my bad. Okay, let us do it again. Model out directory. So let's see what is it having output directory. Okay, output underscore directory. Okay, now you can see like it is creating an empty directory for to store the model. All right. Okay, it is just showing 2 minutes. That's good. But RAM is even not even consuming. So maybe even if it's needed, we can have the batteries to 64. Okay, that's cool. Guys, this is just an experimentation, all right? Like we can't just expect some value. I hope it should do some moderate performance, maybe if you might. But if you want, like you can also go for some heavier models, okay? But or else even Roberta if you need, and then you can train it, okay? For doing the tutorial faster, I just took DistilBERT, alright? But if you want, you can also use BERT. And as you see, I've reduced the samples as well. That also you can increase it, right? Okay, now it's getting evaluated. Let's see what is the what has no attribute accuracy. Self. Oh, Okay. Um, Again, maybe we should restart on time. Okay. Sorry for the delay. Why is it even taking time this much? Right. But the date is correct, right? What? It's fine. What is even happening here? It did work previously, right? Why? One indent does not match any outer indentation level. What? Let me try this. What? Again, now what? Oh, finally. I guess now it should work, guys. Um, Finally, we need to see some inference, right? So let's prepare for that until the model is getting trained. Inference from transformers pipeline pipe equal to pipeline of text hyphen classification we'll have it from here. Mm, okay, we'll give our directory. Okay, config dot model out directory. Okay, So for text, what we'll do is we'll take some random sample from here. Okay, we'll take this. Yeah. Okay. So the accuracy is not so bad. That's kind of okay, I guess, because 78 with some DistilBERT model, it's good. We can also train it in BERT. Okay, not so different. You can just train your BERT model by changing the config. Okay, so from here you can just change it as BERT base uncased, and then same code. Okay, doesn't change anything. And then maybe if you want to have some different name, you can have that. Other than that, the same code will work. Okay, and now coming to adaptation. So whenever you need to load it from local, right? So what you can do is, so instead of having it as self.dataset ID and split, you can have the format of the dataset in which you need to load. Okay, something like this it would be load underscore dataset of, let's say, Parquet. So even I have shown how to load a local dataset. That will be in our previous video chatbot. Okay, and then data files equal to your file path. Okay, so this is how it would be. All right, now it's getting trained. I hope at least we'll reach 80. Okay, it is getting trained. So final stretch. I guess we have given it in lower. Yeah, model out directory, right? Yeah. And guys, when you want to push your model into Hub, right, you need to have an account in Hugging Face Hub, which is not that tough. Okay, you can just create a login. That's all. You can just do a login and you'll get an account. Just make your profile and you can just take your token and then call it here. Okay. So yep. Now it is trying to push to the hub. Okay. It's taking 15 seconds. Right. For this, if you want to have it in your local, just from running here, if you want to have it in local, just mount your drive and then copy this to the drive. Okay. So I'm just gonna try running this now. Let's see if it is working. Can't load tokenizer if we are trying to load. Blah, blah. Okay. So what we'll do is, I guess the tokenizer has not been saved in that. Um, distil BERT hyphen base hyphen unpaste. Let's see. How it is working. Directory, right? Okay. Okay. See, now it's working, guys. That's cool. Uh, So here you can see like you have a great weekend. Everyone will be back to a full schedule next week. SPY, AP, AAPL, blah, blah. So it seems to be a positive one and it has given positive. So yep, uh, that is for our text classification. And yeah, so I'll see you all in the next video. Okay, so this is your project number 2. I'll be uploading one project each week. Okay, at least I'll try to upload one, and if possible I'll upload two. Okay, and if you want your, like, you have some ideas for a project and you want to know like how to do it, make a demonstration out of it, please do let me know in the comment section, or else join a Telegram group. I've given the link in the description. Join there and then ask your queries, or if you want any suggestions for your project, just ask me. I'll just make a video on that. Okay, so yep, our text classifier is working. I'll see you all in the next video. Until then, bye bye.